Hi there, we're going to take a look at a past paper question on acids and bases in this video. It's taken from AQA Year 2, Paper 1, 2017, question 3. The format I'm going to use is black text for the question, red text is additional information, blue text is the answer. Some points may be highlighted during the description. You can pause the video at any time and attempt the question before the answer is revealed. Let's get started. Here's the question. The ionic product of water, Kw, is equal to 2.93 times 10 to the minus 15 moles squared dm to the minus 6 at 10 degrees Celsius. Which is the correct expression for Kw? Well, it's easy to get mixed up between Kw and Kc. The option on the top left is some sort of confusion with Kc, as is the suggestion on the bottom right. The top right suggestion, Kw is equal to H plus multiplied by H2O concentration, that's just simply wrong. You have to know this equation, Kw is equal to H plus concentration multiplied by OH minus concentration. The correct answer is the response on the bottom left. Here's the next part of the question. Calculate the pH of pure water at 10 degrees Celsius. Give your answer to 2 decimal places. In pure water, for every molecule of water that breaks apart, we get one H plus ion and one OH minus ion. So we know that the concentration of H pluses is equal to the concentration of OH minuses. So for pure water, the Kw expression becomes Kw is equal to the concentration of H plus ions squared. Therefore, if we take the square root of that expression, we can find the concentration of H plus ions. We also need to know that pH is given by the negative log to the base 10 of H plus concentration. So if we put the numbers in, we find that the pH of pure water at this temperature is 7.27. Make sure that you address the question. Give your answer to 2 decimal places. Here's the next part of the question. Suggest why this pure water at 10 degrees Celsius is not alkaline. For a substance to be alkaline, there must be more hydroxide ions present than there are protons present. For a substance to be acidic, there must be more protons than hydroxide ions. In pure water, the hydrogen ion concentration is equal to the hydroxide ion concentration. So this is why it is not alkaline. Here's the next part of the question. Calculate the pH of a 0.0131 mole per decimeter cube solution of calcium hydroxide at 10 degrees Celsius. Give your answer to 2 decimal places. The first thing we need to do is work out the concentration of hydroxide ions. Now calcium is in group 2, so calcium hydroxide is CaOH2. If we multiply the 0.0131 mole per decimeter cubed by 2, this gives us the concentration of hydroxide ions. Next, we take the Kw expression and rearrange to make H plus ion concentration the subject. Finally, we use the expression pH is equal to minus log to the base 10 of hydrogen ion concentration to work out the pH. Don't forget to give your answer to 2 decimal places as stated in the question. Here's the final part of the question. The 0.0131 mole per decimeter cube calcium hydroxide solution at 10 degrees Celsius was a saturated solution. A student added 0.013 moles of magnesium hydroxide to 1 decimeter cubed of water at 10 degrees Celsius and stirred the mixture until no more solid dissolved. Predict whether the pH of the magnesium hydroxide solution formed at 10 degrees Celsius is larger than, smaller than, or the same as the pH of calcium hydroxide solution at 10 degrees Celsius. Explain your answer. To address this question, you need to know that the solubility of the group 2 hydroxides increases down the group, and that the greater the hydrogen ion concentration, the higher the pH. So the pH of the magnesium hydroxide solution will be higher. The solubility of the group 2 hydroxides increases down the group. Thanks for taking the time to watch the video. I hope all of the explanations made sense. Take care and goodbye.